And we continue with the day of Postgres today with Hari on the unleashing power of Postgres with the multi-master replication. All right.
Good afternoon. Right. I mean, the sessions after the lunch are the hardest to attend, not to sleep. Right. I'll keep this session as interactive as possible, folks. But if you have any questions, you don't have to wait till the end. No, ask me the question. So the session is a lot more interactive. Thank you. My name is Hari Kiran. I'm a customer success advocate at PGDay. It's a startup. We're working in the Postgres ecosystem, adding the multi-master features to the whole Postgres open source community. I'm going to be talking about, I'm going to scratch the surfaces of how do you transform your single master or a single primary database into a multi-master and make sure you are still within the boundaries or within the Postgres open source ecosystem. Right? That's the main goal or the main motto that we have at PGDay. We have another product which is PGDay Cloud, which is more of a SaaS/DBaaS offering. Now, if you look at what are some of the problems with single master or the current Postgres core, which allows us to scale with n number of read replicas. We can scale using our logical replica, right? Some of the issues that we have found with extensive customer outreach and extensive market research are these three pivotal problems, right? Application users, I'm from India, right? Now I've seen some of the folks from Australia, some of the folks from Europe, US, right? So our application users are spread across the globe, right? But the application servers or the database servers, for now, they are still not yet global. Meaning, you can set up a cloud instance on AWS or some of the cloud voice that we have, right? The Googles or the Azures. But you will end up having one primary instance, right? We see that as one of the problems. We see that as one of the issues. And looked at, hey, what are some of the options we could look at in resolving them. And now one other point is the databases are hard to go global. It involves cost, it involves operational overhead, it involves people, it involves the commissioning and the provisioning and the IT infrastructure overheads. Now, even if you look at the very foundation, the building blocks of setting up a database instance, right? So on your left-hand side is the primary and replica, which is the conventional architecture that we set up. Day in and day out, you use Ansible or Terraform or even a simple Bash script can go ahead and set up this primary and replica. And we would have done this 1,001 times. On the right-hand side, the subtle differences that we would like to introduce is the master, multi-master, right? So if you look at the computing at the the base of it, right, the bottom of your screen, so you've got multiple database servers, all of the servers acting as primaries, which means you will be able to go ahead and write to each and every one of those nodes, right? So that's where the unidirectional replication slightly transforms and advances into a multi-master / bidirectional replication. Bidirectional replication isn't something new for the Postgres ecosystem. It has been there in existence since 9.4. So we had a patched version of 9.4, which allowed us to install the BDR 1.0 extension that made the database to a level, a bidirectional compliant. Now, if you look at some of the advanced users or the enterprises, what are some of the key areas, right? Key areas that some of the companies or some of the enterprises are focusing on, right? Availability is at most one of the important ask, I would say, right? One of the important KRAs, right? So we are talking about, no, we are not even talking about, 2 nines availability anymore, right? So 3 nines and 4 nines availability is something that a lot of the enterprises vouch for. A lot of the enterprises are looking for in the database ecosystem, right? Database platforms. And from a global usage standpoint, right? Like I mentioned about, we have got users across the globe, we have got applications across the globe, right? How do we make sure the database side of the story is also global? Multi-master is one of the ways. I'm not saying it is the only way. I'm saying one of the ways is to go with the multi-master database ecosystem, right? Now this is a lot of the distributed database engineering folks, distributed database companies are looking at, right? So these are the two instances that we are mentioning here, but to the lay of the land is far more bigger than what we have, right? So these are the two studies that I often quote whenever I'm talking to the customers, when I'm talking to the engineering folks, right? Saying, hey, if you, for you, the availability and latency is an important factor, right? You might probably look at these two use cases, right? You might want to take a look at these two instances where you could have safeguarded your IT infrastructure. You could have safeguarded some of the investment that you have made in setting up the database, in making sure the platform is resilient, making sure it is fault tolerant, and so on and so forth, right? The overall IT acumen that should be part and parcel of any database ecosystem per se. And both of them, right? So whenever we look at these latency plus lack of availability, we lose customers, and nobody wants to lose any customers, right? We want to gain customers, we want to acquire customers, and make sure we are on the win-win situation, right? So both the customers have to be 100% available, or at the most 99.99 available, and making sure the applications have minimum to zero latencies, right? So there is a concept called as closer to user, which is to set up the applications, use Cloudflares, the Vercels fastly. We have got now one pod called as Varnish software. They are also in this CDN ecosystem. Every one of these companies or enterprises are going the route of getting the compute, making sure the data, making sure the entire user experience is closer to the user, right? Now, one of the solutions, like I said, right, one of the solutions is PGH platform. This is a pure Postgres and an open source version available. I'll talk about the GitHub and then the URLs. But just to look at a very, very high level perspective of what PGH platform is, right? It is optimized for the network edge, which is, again, closer to the user, and then making sure you are incorporating some of the core fundamentals of edge computing into your database platform. And we support, we talk about this multi-availability zones, multi-region, and then, multi-cloud deployments. As of now, PGH platform supports all the three cloud CSPs, right? The Googles, Azures, and the GCP, right? And then hybrid cloud deployments. So I've been a big fan of, or big advocate of the cloud concentration compliance, right? Which is I mean, you may be having relationship with one of the CSPs, right? Uh, the idea or the point that I'm trying to make is you are risking cloud concentration, which means if that particular cloud has got any issues on that specific region, right? So you are jeopardizing the customer experience, you're jeopardizing a lot of the other stuff. Now, some of the key features of PG Edge platform, if I say, again, this is built on the foundations that we have had for a decade, right? Simon Riggs, one of the the earlier architects of logical replication, rest in peace. The gentleman passed away in an accident, a few weeks ago. He was one of the architects of the logical replication that we are using now, right? And the BDR, the bidirectional replication, open source platforms that we have had. So this, the entire PGH platform is dependent on or based on the PG logical, which is again one of the oldest extensions. A lot of our Postgres engineers know about. And the PGH platform is an asynchronous database replication, I would say. And whenever we talk about multi-masters, so you're talking about data being, processed, data being inserted, returned to, read from multiple master instances, which makes sure there are a lot of guardrails that needs to be implemented. One of them is the conflict resolution and the conflict avoidance. So in a very, very basic sense, if I have to say, there's node 1 and then there is node 2. Both of them are trying to insert a primary key value. You are ending up in a conflict situation, right? For us to make sure the conflicts are not going to be arising, PGH platform has got a couple of guardrails in place. One of them is the CRDTs, the conflict-free replication data types, right? I'm not going to go in depth on some of the points that we have, but I would definitely scratch the surface, right? So again, another important point is the latency-based routing, which is to find the nearest node. Say, for example, a connection request is coming from Thailand. A connection request is coming from Australia. So you would have servers that are closer to that region, and you will identify in an intelligent fashion, hey, what is the K nearest node available, and make sure to send out all those connection requests to that nearest node, right? That is the latency based routing, automatic routing, right? Again, if you are talking about incorporating this logic into your application, it is to go ahead and change your code, change the whole application behavior, and it involves a lot of development activities too. In order to avoid that, we made sure the latency based routing for automation, automating the whole connection concentration layer to the nearest node is available with PGH out of the box, right? And one other important thing is the anti-chaos engine. We call it as ACE. ACE, as the name stands for, it is for something superior. So we have ACE from a validation standpoint, which is, hey, there is node 1, node 2, and node 3. All of them are speaking the same language. From a LSN standpoint, from a SEN standpoint, for all the Oracle folks who know about SEN, and making sure the all 3 nodes have the latest and greatest LSNs and consistent data, right? I'm going to talk about the CAP theorem and what is the components, 2 components of CAP theorem that we have incorporated as part of PG Edge, right? And data residency support again, right? If I have to quote an example of data residency, there's no more good example than GDPR, which is to hold the data within their own region, right? So you will be able to incorporate data residency support out of box, which is to make sure, hey, the region that is available, now they've got 3 regions and then 1 in Europe, all the data that is processed within Europe stays within Europe, right? So you need not have selective replication between the node that is available in Europe, and then you don't have to transmit any data that is GDPR compliant to the other multi-master nodes, right? Which is again, an out-of-box feature that is part and parcel of PG Edge. And I keep saying that open source model and then standard Postgres, right? If you look at this diagram, it's very clearly evident what is the standard Postgres engine and what is part and parcel of PG Edge. What is part and parcel of the PG Edge offering? So if you take a look at it, the top two blocks, right, the PG Edge CLI and the Spock are the only two blocks that are contributed or that is part and parcel of PG Edge platform, right? All the other components, right, including the standard PostgreSQL engine or some of the extensions we have, right? Postgres is famous for its extensibility, meaning if a feature is not available in Postgres core, you will be able to go ahead and look at the internet and see, hey, what is the extension that I can install on my Postgres and get out and perform my tasks, which is not available in the Postgres, within the Postgres core and contrib modules. Now, the Spock is the multi-active replication, which has got that inbuilt conflict resolution in place, right? That's the extension. You will be able to go ahead and download the source code, look at what is the part and parcel of how Spock is built, right? What are some of the building blocks, are the architectural principles that we have incorporated from the erstwhile BDR systems, right? The BDR1s, the BDR2s, and the PG Logical 1 and 2, which are still an open source extensions that are available. And like the categorization here itself is absolutely clear, right? Crystal clear as to if there are any other third-party applications, if there is any other components that you need to have up and running for setting up a PG Edge platform, right? So you should have your standard PSQL Postgres engine and the bunch of extensions that PG Edge supports. Right. Some of the key differentiators that I touched upon, right? So the standard 100% Postgres, which is, if you have a database, Postgres database server, which is running, either Postgres 14 or 15 or the latest and greatest 16, you can download the Spock extension from GitHub. You can, start working on, setting up a multi-master. There's enough documentation we have made available on the pgh.com, right? And this is another important component, right? So the open source versus, we are, for God's sake, we are now talking at FOSS, fully open source software, right? So this is another important, the fabrics and fundamentals of the PG Edge itself, right? So if you want it to be as open as possible, that's why we have this Spock extension and the NodeCTL components already available for download. The source code is available for download on GitHub, right? And one other important thing is, how do you make sure the user experience or the way you are installing the PG Edge plus Postgres is made as easier as possible, right? So all of them are available. And this is the CAP theorem that I was referring to. And PG Edge is eventually consistent AP, right, which is availability and the performance, right? So we are not looking at the consistency, right? So that's one of the reasons we say asynchronous versus the synchronous replication. So whenever we talk about synchronous replication, we are curtailing ourselves from a write latency standpoint, right? Now we are introducing the way, in my opinion, we are introducing latency when we are doing in the writes, right? So though we have got multi-masters in place, though we have got multi-region support, it still hampers your write acceleration, right? That's one of the reasons why we consciously took the asynchronous way. Right. So we have spoken enough about PG Edge. How do we go ahead? How do we go ahead and take a look at some of the deployment options? I said, right. So the most easiest of all is to look at the Docker, right? You just need to download the source code. Go to the GitHub /PG Edge and take a look at the Docker component, the Docker side of the code base. Download it. You go you will be up and running on a Docker setup within a few minutes, right? I have done that multiple times, and then the whole user experience that we want to bring to the community, right? Bring to the developer community is make it as easy as possible for you guys to set it up and then start working on it, right? And then we have got, this is the GitHub URL. The slides will be made available by the FOSS organizers at some point of time. But no, this is the GitHub where you can go download some of the examples and feel free to contribute back to the code repository if you have any thoughts or any issues that you have found, right? And this is the last slide that I have. Any new Postgres technology that gets in, right? Without customers, without customers, we are all doing nothing, right? So this is one of the customer use case that we have from a financial organization. I wouldn't name the financial organization now, but if you look at the general use case, right? The whole the customer experience was at setting up numerous database servers, having a large database team, trying to look at managing and maintaining that database. Now they have shifted to PGDay's platform. They are able to do database distribution successfully. They are able to lower their IT operational cost, and at the same time able to work. Make sure the Postgres engineers that are working on the erstwhile Postgres instances does not have to do any hand holding, meaning you are as good as working on a Postgres database, right? The added components are the Spark and the PGDay's platform utilities like NodeCTL and stuff, right? And these are the benefits that the customer has made, which is highly available system, ultra high available system, making sure the latency numbers are as less as possible, right? Thank you so much. I'm open for any questions.
Okay, do we have any questions? We have.
Thank you. Interacting with multi-master replication that you have a conflict resolution. Can you elaborate? Can you elaborate more about how to resolve?
So if I have to put it very, very, very simple terms, the last commit wins is the algorithm that we are using, making sure whatever is the last commit that wins the conflict. And more often, one of the lead architects that we have as part and parcel of team, Jan Wiek, who's the author of Slony. He always makes sure that instead of having conflict resolution, promote conflict avoidance, which is to make sure there is never a conflict within the database, within this Spark extension that we have built. So instead, looking at conflict resolution, we are pushing towards the conflict avoidance. In case the conflict arises, there are guardrails to make sure that conflict is resolved.
Okay, the long-term issue on multi-master is deadlock.
I'm sorry.
The long-term issue about multi-master is deadlock.
Deadlock, yes.
And deadlock can happen anytime, and we cannot do anything because both of them is independent.
Right.
What do you mean with conflict avoidance? Do you regulate the transaction between two machines?
So there is something called as snowflake sequences that we have introduced. That is again, a public Git repo that is available, and Jan is going to be talking about in the PG dev, right? That is the conflict avoidance that we have introduced as part and parcel of Spark.
Okay, thank you.
Cheers. Any other questions?
I have one.
Please.
When you say multi-master, do you write all the masters, or do you write the primaries, or do you write only one primary?
We write to all the master instances that are qualified and set up as masters. So if you look at the whole database setup per se, right, you will have now 3 regions, now 3 nodes, and it can have its own logical replicas and physical replicas. You qualify these 3 nodes, the 3 regions and 3 nodes as masters. Yes, we go ahead and write to all the masters, and they eventually get consistent.
Okay. Any other questions? All right. Thank you very much.
Thank you. Thank you all.
Plug that in. Is that an HDMI port?
I guess we're ready for the next talk. Gilles from Excel Cluster will take us to the PostgreSQL Security Assessments. Thank you. Hi, everybody. So, the purpose of this talk is about the way to check your PostgreSQL cluster security. And most of all, how to automate this check. I don't know if you are like me. I have very bad memory, and there is almost around 80 security check to perform on a PostgreSQL cluster. and honestly, most of the time I am missing some of them. So this talk is more about how to automate this test to avoid missing some checks. So my point of view is that for the community, we need such a tool to be able to enforce the security of PostgreSQL cluster in the world, and because in my DBA life, I see a lot of PostgreSQL cluster with very few securities. So we need such a tool. Some words about me. I'm the author of PG Badger, PG Formatter, PG Clue, and a lot of extension and other tools for Postgres. I'm also the CTO of the ExaCluster company, which is specialized in database migration to Postgres and PostgreSQL support too. She's a company that is sponsoring all my developments and all the tools that you can find on my GitHub repository and some of the GitHub repositories. Thanks to them. So the question is how to secure your PostgreSQL cluster and what to check exactly. This is the main question. The problem is to know all the checks have to be performed, and there is several ones, as I said. So hopefully there is a document what was created by the Center of Internet Security, CIS, which gives almost all the list of the security checks that have to be performed on a PostgreSQL cluster. So it is available online. It is for free. You just have to register, and you will have this document. There is also some recommendation from the DISA, which is for most of the part redundant was with the first one, but and it's much more difficult to read. So if you, but there is a lot of information too. Yeah. About data check security, there is a lot of articles produced by the European community, which is under the law GDPR, called GDPR, where you have a lot of recommendation to, and this is a law, to protect user data privacy. So I will not talk about this here because what I will present you is very new, and I have not had the time to work on it, but it's on the way. Yeah. There are different areas where we have to check security, and the first one is operating system. At operating systems, there are a lot of security questions, but I will not talk about the Linux part. This is the job of the sysadmin to secure your Linux box. Here, this is just the checks that must be done for DBAs. So ensuring that your PostgreSQL package come from a no source, and especially I recommend to use the PostgreSQL repository. This is something especially for maintaining your PostgreSQL cluster and upgrading your minor version. Looking at if PostgreSQL is start at boot can be something valuable to do, and especially verify how you are following the minor version in your PostgreSQL cluster. This is really important to follow the minor version, and same, it's very it's often that we can see some PostgreSQL cluster with several minor version back from the current one, and it must be checked every time that you have the last one version, especially for security updates and bugs, of course. About the SUDO, you have to be sure that no other Unix user on the Postgres cluster is able to use the PostgreSQL cluster privilege to escalate the privilege on the PostgreSQL cluster. Yeah. This is very important. At file systems, there is also several things that must be checked. Some of them are already checked by Postgres itself when it starts, especially the permission on the PG data or some other checks. But some are not done. Especially one I recommend is check if the PG data has checksum enabled. This is not something that is part of the CIS recommendation, but I think it's something that must be done to be able to detect silent corruption on your PostgreSQL cluster. The different partitions, this is to avoid filling disk and having a DOS with such a configuration. Some check here are not part of the CIS, as I said. I have had around 25 additional checks because of my experience and why we can see in PostgreSQL cluster. Of course, PostgreSQL configuration must be checked. This is very important, especially the runtime parameters that are started by the backend. It is possible to have a DOS, especially, for example, you can disable the use of the index in the PG catalog when you start Postgres. So it's important, and if you disable this kind of index, you are sure that your client will have a lot of performance issues. So it is important to check that someone at one time have not changed these parameters, and etc. Other parameters, all parameters that are start by the backend at runtime can be checked automatically. All the other one, postmaster, CGAPs, super user, privilege, and runtime must be checked by the DBA. So the objective of the tool here is to present this all these parameters to be checked by the DBA. Logs. This is one of the most important part for securing your PostgreSQL cluster. You have to be able to get whole trace of what happened on your server, or at least be able to know where the problem come from. If it come from outside, or this was a local connection, etc. It is easy with the wrong configuration to not log everything that should be interesting for the DBA, or even worse, to have nothing in the logs. This is really easy with a misconfiguration to cannot find anything in your logs. So it's very important to check that, especially tracing connection, disconnection. It's very important to know at which time someone has connected and could have been done something on your server. Ensuring that you have a logline prefix on your PostgreSQL .conf that is compatible with PGBadger. It's important too, and it's a recommendation of the CIS. So I'm pleased to add it to this tool. Ensure that the log directory are outside the PG data now with the SSD disk. We can see that most of the log directory stay in the same directory in the PG data. This is really something to not do, because with each log you can fill your PG data too. You might also want to enable an audit on your PostgreSQL cluster with PG audit, the extension PG audit, which is allow you to trace exactly what the user have been done, and especially for all the DDLs that has run on your Postgres server. So this is something you have to consider. User connection must be enforced. This is something. This is where it starts for most of the attacks. Ensure you have a password complexity enabled. If you have an external authentication like LDAP or GSS, maybe you have already something, some enforcements in the password complexity. If you create the user in the PostgreSQL instance, you don't have any possibility to enforce the complexity of the password, except by using an extension. I would recommend you CredCheck, which is an extension with doing a lot of things to enforce the complexity of the password, and it also gives you some more advanced feature to enforce the connection from the user. Authentication timeout also is something that must be verified, and authentication delay. It's important to limit the possibility for a user to repeat tons of connection on your server. You have to stop that at some point. With CredCheck, for example, you can ban a user that have let's say three connection attempts, and you can ban it if the 3 connection fail. This is something interesting. Of course, you all know the trust method in the pghbf.conf. So the tools need also to check your pghbf.conf to see if it is well configured, if it is not too much permissive, especially I have seen some installation with, honestly, the person don't know exactly how the net mask and the IP address marks works. So everything, this was an open bar. So a tool that can check that and verify that there is not a mistake, it's a good point. This level can be critical also for data security, especially for excessive data privilege, super user, create role, create DB, and the set, the function privilege, which are security definer clause. Encryption at some level also are need. Especially, I think the PG data need to be encrypted, but it really depends on your security policies. But this is something that you may want to check. SSL, TLS must be enabled. You can also check if you want the FIPS enforcement, OpenSSL cryptography enforcement. Well, I have given the link if you want to enable it. And it check also if you have a PG crypto or PG sodium encryption library. So let me introduce PGDay DBSAT, which is a tool that aims to perform all automatic check about security of a PostgreSQL cluster and collect all the information that the DBA need to check manually. You know I love Perl, so this is a Perl script. With no dependency, it don't bother to install tons of dependency. You just put it on your Postgres cluster and it will work. It performs all security check by calling system command and PSQL command. So you don't need anything else on your cluster. It is a multi-language. There is one translation in French or one translation in English, following where you come from. There is two kind of report, HTML, which I recommend you, and text. Text perhaps it's better if you want to make some diff on several runs. There is about around 80 security check. This is a tool that must be run as Postgres user. If you have set a PG pass or all your PG environment variable set, you can just run the command and send the output to a file. You can also set the usual parameter with PSQL to connect to the instance, choose the format and get an output. And what kind of output? This is the HTML output. You have first in the report the summary of all the checks that have been done with a check if it's set correctly. So green, it's okay. Red, it's there is a problem. It's not well configured. And if you see the square, empty square, this is a check that must be done manually. So all the 80 tests will be presented like that. And after that, you can click on in any check to see the detailed report. And for each check, you have a detailed report, which is explaining what is the check have been done, and if it passed successful, or what problem you have found with this check. There is warning, there is critical, for some part, there is critical part. Maybe it should be reviewed because this is a first draft of the application, so maybe I have to review this. You can see full example of this report on the internet. I have put them on my website. This is a fresh program, so there is a to-do list. Most of this system, I have planned to work on this system in the year. I don't know if I can be able to end all this works in the year, but I will try. I have in the idea to also with this check to be able to detect if you have some misuse in your store procedures with identity object, identity name object. So, but I want also to develop an extension to act as a firewall to not to prevent in SQL in a SQL injection in your in PostgreSQL control. Contributing is important. As I say, this is a new tool, so I need a lot of feedback. I need a feature request, and I need more check. So we have discussed yesterday night with Julian, and we have found some new check that have been applied to the release. But there is some other in the to-do list. Don't hesitate to report bugs. There may be some. Report feature requests and give feedback. My objective is to develop a tool, a community tool, to be able to enforce the security on the PostgreSQL cluster. So if everyone use it and contribute to this tool, we can have something common for all together. And this is the objective. Thank you.
Great, thank you. We have time to take questions. Any questions? No.
That's very interesting. Oh, sorry. Just here, okay. That's very interesting because it is really needed by business people to understand whether their system is secure or not. But you only mentioning the GDPR. It is possible that we are using to comply with the PCI DSS and also like ISO 27001. Mm-hmm. So after we create some scripts like that, and then how can we make it a standard so people can accept it as a compliance, the standard compliance? Is that possible?
I will try to all the new checks that I have produced. I will try to send them to CIS to if they want to get it in another version of the document. And I think this is a good start for a standard on security, helping also CIS to detect to list all the security problems that can be checked in that should be checked in a PostgreSQL cluster.
Do we have any other questions?
Or make
Or
PGD set the standard.
I have one if no one's asking. I always have questions. What was the motive that you actually took this tool or the script in Perl instead of...
Why Perl?
Yeah, why, in short, why Perl?
Because I talk Perl before French, you know. This is my native language. Yeah, this is the reason.
That's the answer.
Also because everyone is doing Python or Rust or anything, but don't forget Perl. This is something. This is almost all called to system commands.
Correct.
So this is the best tool to call system commands.
Yes, but Perl has its own drawbacks and difficulties with the libraries.
I was able to develop that in few days in Perl. If I have used any other language, it take me months. So yeah.
Right. All right. Thank you very much.
Thank you.
We need a coffee break, I guess, but before everyone goes to sleep, we continue with the next talk. Ajit is going to take us to high availability, disaster recovery, and fall turns with Postgres story. Let's start.
Thanks. First of all, thank you very much for everyone giving me this opportunity to speak on this topic. I really thanks to FOSSASIA committee on this. So, yeah, so today my talk on high availability, disaster recovery, fault tolerance, and how you can solve that with Postgres solution. I know that many of the speaker before me talk about some of this topic, and I'm going to try to see that how I can differentiate that, or maybe talk on that, right? So my mostly focus on understand the HADR and fault tolerance, right? A lot of the customers or users may simplify or not to simplify in these differentiate. I'm talking that, and how you can solve this with the Postgres solution. Bit talk on different kind of solution on that, and maybe final thought about how you can choose one over other, right? Uh, so who hell I am, right? So I'm Ajit Gadge. I'm field CTO, work with Enterprise DB. I'm based out of Singapore. Been in industry more than 2 decades, and with the Postgres more than 13, 14 years now. So yeah, so I'm speaking many of these conferences, especially this part of world. So let's talk about HADR and fault tolerance system and talk about their characteristics, right? There may be many of the users confuse between everything in the same bucket. So bit difference in my opinion. So these are some of the situations where high availability, disaster recovery, and fault tolerance system occurs, right? And especially in the Postgres case, or maybe many of the database user case. Very high level, when you talk about HA, you talk about the single data center or single region, right? You not talk about the cross the region, right? That's a HA kind of system. And then you expect like 99.5 system, RTO, RPO. I'm going to talk about RTO and RPO. Maybe you expect some kind of failover in RTO. You expect zero or not zero, near zero data loss kind of system. And moment you talk about the disaster recovery, you being talk about the cross region, not the single region or cross data center. So how you can avoid this kind of problems, especially when this occurs, when there is a really big outage like flood or earthquake, or unfortunately the data center electricity down or something like that, you expect disaster recovery systems. How you can build this kind of system using a different Postgres solution. Of course, you expect bit more RTO, which is a recovery time, because the whole region down. So you expect some recovery more time on that. And then you are, of course, you expect some kind of data loss because again, the whole region down. So the different solution based on these two systems. But there are applications which is really do not require downtime, right? And then you come in a fault tolerance kind of system, which is a mix and match of reliability and disaster recovery, right? But then why everybody is not gone FT, right? And there are some different mechanism to configure that. You of course need a more investment, more server to configure these kind of system, different solutions. So uh, let's talk about CAPS theorem. I'm sure some of you guys know about the CAPS theorem, but then just to repeat, CAPS is C stand for consistency. So either you get the right data which you receive or no data, right? So you make sure that it's a consistent data which is coming to the Postgres server. So not the wrong data you can read and write when you get the read specifically, right? When you talk about the availability, right? So every request which you receive, right, it should be available to the user, even in the case of fault tolerance or the fault or maybe the network partition, right? And the partition tolerance, you have a typically you have a partitioning. When I say partition, the network fail or something is failed, then how you can avoid that, and in that situation how you can configure the systems. And in my opinion, you can either have one of these. If you have a network partitioning, you either have a consistency or availability. That's a trade-off. You cannot have everything in a single basket when the network partition happens. And this will definitely impact on your performance as well. The moment you try to get the more consistent system, then it will require the same kind of replication. I'm going to talk on that. But then you impact on your performance. And you need to choose and wisely what your business needs, what your system needs. Based on that, you can configure that, because Postgres do have a different kind of solution, and based on your need, you can configure this kind of system. Now, this diagram shows you what is the RPO and RTO, recovery point objective and recovery time objective, right? RPO typically measure in terms of data loss. How much data loss you are okay when the system is failed, right? Of course, nobody want a data loss, but then you need to trade off, right? Whether you want a few second data loss, few minute data loss, that's a RPO you need to measure. While RTO is how much time you are okay to not to continue with your business. 5 minutes, 10 minutes. And again, it is not a single time. When I say single time, that means no, typically it's measured in whole year or whole month, right? Based on your availability. So you need to choose what is your RPO and RTO. And again, as I mentioned, its impact on your some of the performance based on you how you configured. But in industry, typically it's measured in a percentage, right? 29, 39, 49, based on the combination of availability. And based on that, you can measure this. Now, how you convert that in the typical standard is, if you are saying that my system is available 99% whole year, that means you expect 3.15 hours downtime, including your maintenance, whether you're doing a patching, vacuuming, all these things. And this goes narrow down toward the even the higher system, like up to 5 nines with the 5-minute downtime in the whole year. And then you can measure that into the month as well, depends upon how you can configure. So it's not a single time, it's a whole year, because you may do the maintenance in the whole year, patching, upgrade, and all these things. So you need to configure based on your requirement, how you design your RPO, RTO, and different kind of solution. Now, this is all about the understanding of RPO and RTO. Let me check my time as well. I need to see the time as well. These are based on your RTO and RPO. And this is understanding of CAPS theorem. This is understanding of the different situations, how you manage the HADR kind of solution. Now, let's talk about the solution, what Postgres do have, right? How Postgres can help you to avoid or resolve this kind of system. So very high level, so there are two major things. One is how you replicate the data. That's one portion. And then how you can do automatic failure if in case need to do the automatic failure. I'll talk first about the replication mechanism. The very basic, again, many of my earlier speaker talk about that. But the three things, one is the physical replication in between the two servers, which is we typically call in Postgres streaming replication. And the second is the logical replication, right? These are the two mechanisms in Postgres or process where you can replicate the data. There is a third one, you can share the disk. Instead of replicating data, you share the disk. That required a third-party solution like Red Hat cluster solution. But I'm not going to talk on this today. I'm going to talk on the replication mechanism. Now, streaming replication, some of you guys know about this, is a bit by bit stream to be moved from the WAL files, moved from the one side to the primary side to the standby side. You can configure based on your need again. If you need a RPO, which I mentioned is absolutely 0, then you can configure the sync replica. And in sync, you have multiple methods: sync on, sync off, write apply, write available. Depends upon, again, your RPO ratio, where you system fail. And then you have async replication, which is a by default, where near 0 downtime is required. Then you can get the async replica, but it will give you the better performance compared to sync replica. So this is a very easy method to replicate the in Postgres from primary server to the standby server. You can do the cascading as well if you require. But yeah, this is a very easy method. Most of the users use a streaming replication, even including the viability as well. Now, this is, of course, the primary side. You can do the read and write, while the standby one can use for the read as well if you required. The second method is, before that, there are some limitations. Compare again with the logical replication, with the physical replica, right? Typically, physical replica take a read and write in a single server, not in the other server, in case if comparing with the multi-master kind of solution. But then failover length of the physical replication also take time, because it need to be fail, detect, and apply, right? So take typically 30 to 60 seconds in case if you're using a physical replication. And then everything you're doing on the maintenance job, especially indexing, vacuuming, from primary server, it goes to the standby server. So you expect those kind of things on the standby server as well. And physical replication don't do the filtering of data. If you require to filter the data, you do everything or nothing, right? So those are some of the limitation, I would say, again, compared to the logical replication. I'm going to talk on that. The one more limitation, I would say, that it required same binaries from either primary and the standby. So I just have 5 minutes. Okay. So this is a logical replication. Logical replication, I think one of the speakers talk about in detail. Logical replication on the top of the, if you're comparing with the physical replication, is that you can avoid some of the limitation in logical replication, because you can actually filter some of the data, right, on a logical replication. It's based on a PubSub model, application subscriber model. I'm not going in detail. I'm just scratching the surface over here. And let's talk about the cluster management solution. The data is replicating. Now, how you can do the auto failover in between this, right? So these are some of the solutions. I'm not saying all, which is typically used by the users. Patroni is one of the great tool which can be used for the failover purpose, auto failover purpose, based on a RAF consensus. I'm going to talk on that. And then Rep Manager is another solution. And EFM is Enterprise Failure Managers from the EDB solution. But these are the really great tool, Patroni and Rep Manager. You can use this as well. So one of the architecture using a Patroni is Patroni is based on RAF consensus, required etcd small key value pair, which can you load on the another VM or maybe on the same server, depends on that. But ideally is another VM, and then you require a proxy to land the connection, and you require at least 2 VMs or 2 server to land a VM for the high availability purpose. Bit complex, but then is really good solution, especially on the VM or physical or even the Kubernetes as well. And one of the solution, if you are comparing with that, this is a EDB failure manager, which is on a virtual IP base, bit simple, but it does have its own limitation as well. It doesn't take all of the failure cases, right? And it does have some limitation on auto failback based on JGroup or Java group, the solution. Now, I'll not talk much because I have a limitation, but then one of the thing, the logical replication limitation is it doesn't replicate the DDL. I think it is under consideration, but then improvement in the logical replication you can do with the DDL. It doesn't do the auto failure by default. It requires some kind of proxy, and if the node is failed, it doesn't fail back again. So that's what the distributed Postgres is coming in the picture. PGD again is from the EDB. It does data sovereignty across the geo. If you have across the geo replication required, it does the conflict resolution. It does the conflict detection, and then you can avoid the conflict as well in this. It does have an automatic failure. So very high level. This is kind of architecture you can see in the PGD. You have one region, you have another region. Across the geo, you can do the failure, and within a region, and across the region, you can do the automatic failure as well. So all of this can be possible. Is one of the solution and it does have a 2-part. One is a BDR, which is a bidirectional replication. On top of that, it does have a proxy, which is a PGD proxy, which can divert your workload in case there is a failure happen. Yeah, so I will skip this slide, but I will talk about one. Now, which one to choose? There are multiple options, right? In my opinion, you should take about the 3 things or 3-4 things. One is a location preference. Are you really want HA or DR or HA in a single region or across the region? Based on that, you can choose which solution you want, right? What kind of RPO and RTO required? You absolutely want 0 or near 0 is okay with you, right? You want recovery should come from the backup server. Again, to talk about backup, but you can do the recovery in backup, or you want recovery from the failure system as well. And then the performance. So performance is really important because the moment you go on a sync, you want RPO 0, you expect impact in the performance. So based on the different solution, you can configure, based on the different requirement, you can configure the different solution using a Postgres different features. I think my time is over. Thank you very much for this. This is my email ID and GitHub. You can follow me on this. I've written some nice PG vector scripts. You can follow me on the GitHub as well. Thank you. Any question?
Okay, we have time for questions.
Any question? Yeah.
When we talk about multi-master, or binary replication or something else, I see each time the same problem. It's a problem of performance.
Yeah.
You know, on different nodes, you have different data in shared memory, in caches, in buffers. Also, you have vacuum made in different time. So sometimes logical replica works much worse than master. How you strike this problem? How you solve this problem of different performance?
Yeah, so if you're comparing, so in a multi-master, again, if you're comparing the only basically with logical replication with the physical replication, right? Then I do not have a right now link or slide, but Enterprise DB do have a public, I would say, the performance benchmarking between the physical replication and the logical replication. The moment you start increasing your workload, the number of users, the performance of logical replication, especially I'm talking about the BDR case, right? It almost same or bit higher compared to the physical replication. And we have a, I do not have right now link, but I can send you the link on that where you can compare that performance. Now, this is a case of when you configured it the async replication, not the multi-master with the sync replication. By the way, BDR do have a sync replication as well with group commit or with the different kind of latency commit. Depends upon how you want to configure the sync replica as well within a BDR. But if you are comparing with async replica with logical replication or BDR or async replication with physical replication, the moment you start increasing the number of user, your performance either same or bit higher in logical. I'll send you the link on that. Yeah.
Okay.
Any question?
Any other questions? We have time for one more question, maybe two. You have credits if you want to use it.
So you can ask the question, no problem.
Okay, thank you very much.
Thank you very much.
Let's
Okay, now we're in the next talk. Today, a lot of security and compliance talks, and great job by the, I need to say good things about the conference committee, putting all these good HA, disaster recovery, failover, encryption, and talks. So we have Julyanto from Equinox will take us to the journey of encryption in 11 DB Postgres.
Thank you very much. Good afternoon, everybody. Nobody. Already late, so maybe we quite tired, but please don't be tired because I will bring you a quite heavy discussion today. I am accompanied by my assistant, human AI. Her name is Irene, so AI. Okay, so I introduce her because she may be learning something. Yeah. Okay. Maybe first of all, we should pay tribute, respect to Mr. Simon Rick. He was a big contributor of PostgreSQL. Maybe we should take what is it time? 5 seconds, okay. He is the major contributor, and he is the one behind the PG audit, replications, point recovery, and so many things. Thank you. And also, I want to say Selamat Hari Raya for any one of you who maybe celebrate for tomorrow. Selamat Hari Raya Lebaran. Anyone from Indonesia? Oh, my brother. Okay, next. So it is me. Maybe for the one who didn't know yet, I'm running IT solution in Indonesia and Southeast Asian. We also having some event in Bali and also in Singapore and in the past, PGDay, PG conference, etc. So I think enough from me. Okay, this is a memory from 2019 and when we are in the Bali PG conference. Yeah, some of them is here right now. Raise your hand. Okay. Okay, so PostgreSQL is derived into 11 DB Postgres, and this is our product. So basically, this is a proprietary, but we also are following the the versioning of the Postgres. If you want to test the 11 DB Postgres with the encryption, you can go to 11db/.asia/register. So 11 Postgres already implemented in so many clients in Indonesia. So you can see the logo here. It mostly is corporations. So this is something like we take a part of is we are avoiding this corporation not to use Oracle and instead use Postgres. So this is our milestone. Maybe I will skip. So maybe the question is why we need encryption in RDBMS? Because I saw from the beginning since last day, so many students. So I have to start from the beginning. Why we need encryption in RDBMS? So first, it is business need secure transaction. Transaction should be secure by RDBMS, not NoSQL or any kind of things, because business need to be secure by atomicity, consistency, isolation, and durability. So the transaction also need to be by something like encryption or anything else, and then multiple party involved in data management, since the data is designed, and then there is a business development, solution architect, data analyst, administrator, and etc. There are so many party involved. So if we don't create the privilege escalation, right privilege escalation, maybe we have facing some problem because maybe there is some data breach. Yeah. So also we need to comply with GDPR, PCI DSS, and ISO 27001. It is for data management. So because there are so many compliant regulations nowadays, I think we need to move forward into something better. It is, in this case, is encryption. And also minimize the potential fraud, since usually internal fraud is caused by internal. Yeah. If you had any question, feel free to ask. So maybe we can elaborate more information. Okay. Based on the analysis that we conduct to the regulations for this, it is GDPR, we saw some articles which is indeed require first unauthorized. So it is we have to create something like authorizations method, a better authorization method, and then we can see encryption, and and then only personal data which is necessary, blah blah blah. So based on these articles from GDPR, it is concluding that encryption is required for creating a better security in data management. And also, we try to check also in ISO 27001. There is some articles also regarding encryptions, cryptography, access control, and prevention. And we in Indonesia we have a law derived from GDPR. We call it UU PDB, Undang-Undang Perlindungan Data Pribadi. It is also mentioning something like before, then about access and security level. Okay, so this is enough to us to go forward. Why we should have something like a better encryption, better security in data management. So what is the challenge? The challenge, first, I think when we talk about encryption, we should understand that in this recent world, there is already a quantum computer can do their work. Even though maybe only a very simple one to calculate, but it's possible. Some encryption that we have, that we use right now, it is, we call it not quantum safe. So we have to use the encryption which is quantum safe. There is what is it issue from NEST, I think, to about information which encryption that should be used in business. So it is comply with the quantum safe. And then also quantum safe, that's the first challenge that we should comply. And then the compliance to end-to-end security. To comply the end-to-end security, I think we should implement something like SSM, hardware security modules. And then, but it should also be easy to use. It's we call it a transparent or seamless. So we should have an encryption method which is quite transparent or quite easy to use. And then support multi-factor for authentication and authorization. Of course, backup and restore should be there. And then, yeah, it should not be it should not be performance degradation. Yeah. So these points that we try to analyze before we create this method. And then we try to create column-based encryption in the RDB in the Postgres. Actually, it uses data type, and then because it is column-based, so it has to have index, so it is able to search fast enough. Because if we encrypt the column and then we want to search inside the encrypted column, so we have to scan and to decrypt. So it is not flexible, it's not efficient. So maybe it is maybe for the student who maybe didn't really understand about data state. Yeah. So there is three state of data. First is data at rest, which is the data it is on the storage, and then the data in transit, it is when data transmitted in the network, and data in use, it is when the data in the memory. So if we talk about encryption, which state we should encrypt? Usually we prefer to use at least the data at rest, and then data in transit, maybe in use, maybe not, maybe yes, maybe not. So data in transit is very easy because we already have TLS, SSL, and VPN, something like that. But data at rest maybe another challenge. But some technology can be used like storage-based encryption. So I can go next. So if you use like something like this, storage-based encryption, it is very easy because the database didn't know it is encrypted or not. This is in the file system or in the operating system. And we can also create encryption in the application level. So the application itself encrypt the data before put on the database. So the problem is in the applications. This also can be done, but this is also another problem raised because how we manage the key. And then the third is the encryption, and the encryption is done by the database. So we can say it is transparently from the applications because application didn't know whether it is encrypted or not. Also, encryption didn't know where is the key to encrypt and decrypt because it is done by database. So we choose this approach. Yeah, the encryption is done by database, and yeah, it is. So based on the picture, you can see this is the Postgres, and this is the agent. We create an agent for Postgres. So this agent function for what is it? Facilitate the database. For example, like DBA access to the agent, and agent will modify something setting in the database. And the agent itself communicate with SSM. Okay, maybe anyone understand about or maybe see about SSM? Raise your hand. SSM. Okay, thank you. And we also create a mobile application. We call it Charaka. Charaka is Sanskrit, means messenger. Is that correct? Yeah. So we use mobile help for authentications because in the encryption we can encrypt the data inside using data type, but how we can ensure the user can access? So we create another type of authentications, and by using Charaka as a mobile apps, we can create something like offline OTP. Yeah. So applications in the what is it protection level, it should connect first to the out iconic out service to get a token what is it session. Yeah, to get session, this is this session would be used to connect to the database. So when application with their connection string breached by some attacker, the string, yeah, which is usually put on the code, cannot be used for attacker to connect to database, since it should require to use communication to the iconic out service. That's another kind of protection that we develop for SA. SA means iconic seamless encryptions. So yeah, this is for applications connect to the Equinix out service. We will show you the demo later. And after they get the content string, they can access to the database. And when database is restart, this database cannot be restarted by itself without any consent from the owner. So the database owner used Charaka Mobile to give consent whether the database able to be restarted or not. Because trying to restart the database is another security concern. We can trying to take a key or maybe something else from the database. So this picture is a complete explanation about the needed of implementation of encryption in 11DB. I will tell you more a bit about index and anything else later, but at least you can see the topology first. So what we call it end-to-end encryption, it is the key for encrypt and decrypt. It is on the SSM, and database will inquiry to the 11DB Postgres before they can get the key from SSM. Yeah. So nobody, whether the database or the agent, has access persistently to the key. Okay. Maybe up to this step, any questions? Or I just move first, yeah? Okay. So this is the demo explaining about how we implement the encryption in the database. I will start and stop while I'm explaining the steps. Start. Okay. Okay. So this first time, one should register to the system. You can use the 11db.asia register, and this registration we collect to create a profile of user, and then when user register and download the package, inside the package there is a what is it? We call it random seed to create a synchronous OTP. Okay, maybe it's just, I'll need to faster a bit. So at the first time, we only support online SSM, but later you can use SSM. Or you can use TPM. TPM is Trusted Platform Module. You just lie on the board usually. TPM can act as a SSM, but very less functions. So this already done. And then we will and linking the applications. So yeah, we download from QR code, and then because we are not registered yet into Google Apps, so sorry, we have to download it manually, and we have to install manually. Okay. And then registration, it is from email. We put on the cara to link the mobile phone into the system to to link us to the mobile phone. Okay. Okay. So we create a package, Debian and RPM. So you can try to use Deb or RPM. Yeah. This is installing. After installing, so the database already there, the agent also there, and also we install libpam. If you wish to try to install, you have to be careful, because this installation put libpam on your OS, and then your OS becoming more secure, because there is another kind of authentications. Like you can see sudo ls-l. So before we don't ask challenge, right now they ask for challenge. This challenge should be used this mobile applications. We have to put this number to the mobile apps. And then we get the response from the mobile apps and put on the host. Okay, so that stage is we enabling the sudo into 2FA using offline OTP. We call it offline because the host and the mobile is not connected, and I mean the host didn't connect to the mobile, of course, connect to the internet, but between host and internet, any connection. Okay, so this is why we call it 2FA, offline OTP. Sorry, yeah. Okay, and then this is also the main reason of having 2FA is to preventing the Postgres starting up without any consent. So we also already start the Postgres, but it didn't finish the starting up, waiting for OTP, and we should open the website localhost locally, and we use the same mechanism to FA. Okay, then the database start. So that's the reason why we enabling 2FA. So this demo for showing the encryption. Yeah. First thing first, we using user. Yeah, you're creating user, database user. Okay. Okay. So, and grant SL1, SL2, SL3 role we use for level of access privilege. Okay. Okay, so we are connecting to the system using trial one. It means the owner, and the owner create another user called Ananta, and Ananta has SL4, and Budi has SL2. It means Ananta has higher privilege than Budi. And then, yeah, this normal, grant all privilege to schema public, on schema public to Ananta and Budi. Okay. Then we will login as Ananta, and then we will create table and is okay. Begin. This is the first column, and the second column username is varchar, and the third column is mother. This name is ASEC. ASEC is our data type. This is encrypted data type. And then we insert the data. Okay, we have 3 rows. Insert, okay. Then we create index. This index is special index created for this kind of data type, ASEC. So therefore, by using this index, so we can search, unless we cannot search. We have the name like, we can use like. Okay, can search. And then we login as Budi. Remember that Budi only level 2. So Budi cannot see. But this in this type, wait a minute. Budi is not granted permission to table. It is Postgres, not us. Yeah, we have to grant permission to table. Grant all on users to Budi. So Budi can access the table. But still, Budi can access, but Budi cannot see because Budi doesn't have SL4. Because when Ananta create the when Ananta creates, Ananta is level 4. So yeah. So Budi will try to select, can see, but cannot see the plain text because it doesn't have the same rights with Ananta. So we have to grant SL4 to Budi, so Budi can see the plain text. This is a real case demo. Okay, Budi can see the result. Any question perhaps?
Okay. Any questions?
I have a simple question. In a database system, we have checksums to control consistency. and
checksum.
checksum, yes.
Checksum.
They reduce our performance, but they strongly needed. Can they get something beneficial from introducing encryption in core of Postgres? Remember that it can reduce our performance a lot. So do we need implement it? Can we get something from that?
Yeah. Okay. As far as I know, PG checksum is not used anymore, right? Because it's not really good. Maybe Julian know better than me. And why? Because computation run in every row. If the encryption also run in every row, I think we'll have the same thing happen. But we're trying to make it faster because we use hardware accelerated encryption. Since the processor actually has feature of AES, yeah. We use AES 256, and we use the hardware encryption from AMD or Intel. And also, we didn't decrypt every select. When you saw it, maybe in the table there are million of rows. When search, they are only using index. The index is we create a mechanism and algorithm to the index, and when index is being used, it don't revealing the clear text, because index only contain code, something like that. And then when the data already collected from the filter, we select to the page and we use we take the encrypted data from the page and decrypt it. So we didn't use encryption, decryption every time. So I think we cannot use for checksum because it will result the same thing.
Get some beneficial thing in introducing encryption in core. Maybe we should have it as a middleware outside the database. I'm just curious about that. Do we need to introduce it in the core?
In the core?
Yeah, or not? What do you think about that?
What do you say? What do you mean with core?
In Postgres core.
From the server level.
Oh,
on the server level.
On the not only data type, but in the core. I don't know. I don't have any idea, but because we're using data type, we already done. I think for the business side, what business need is not all data being encrypted. They need something very confidential, or maybe they just need anonymity, like Julian bring yesterday, to avoid people can refer to one people to another data. But for more secure, to avoid stealing the data, when maybe somebody can steal through the back door, because it's encrypted and it is AES-256, I think it's not easy to get it. The plain text, yeah, it's not easy. And
Okay.
also quantum proof.
Okay, thank you very much.
Yep. Thank you.
We're out of time. We'll take a break, and then we'll come back at 4. We have more sessions after 4, after the coffee break.
Hello, everyone. So in this talk, I'm going to talk about like what are the possibilities of GIS and where is the market opportunities are going around that one. It will not be a fully technical talks. It is like kind of understanding the use cases, what are people are building around that, and how the Postgres, which is having the extension called PostGIS, can be used to empower that and build a GIS application. So that's how the title also called that, harnessing the power of the Postgres for the GIS. So before that, let me just introduce myself. So as he is mentioned, my name is Avinash Shashikant Dalvi, but people call me Avi. I'm a senior software engineer at EagleView. EagleView also in GIS domain in the imagery side. At the profession, I'm a full stack developer and AWS community builder. It is selected by the AWS. So also along with that, co-organizer for Docker Bangalore meetups, and I do multiple community contribution, volunteer, and to speak in a multiple community events also. And here the blogs, the Internet Katta, where I keep writing the blogs. It's almost like from last 13 years I'm writing the blog. It's about all learnings, experience, and the failure what I have gone through the last 12 years. Like, and my portfolio. Okay, so let's go to the, just keep it to that one. So I have kept like the similar kind of sense of that particular GIS. So we are going to route like this one, start with the GIS, understanding the trend, and then what are the types will be there, PostgreSQL and functions and use cases. So some of the technical thing I might skip it due to the time restrictions, but we'll see that how the time goes on. Okay, so he's a Waldo Tobler. He is a very special American geographer, cartographer also. What he said that, right? He said that everything is related to everything else. Means that to understand the GIS, nothing is a complex, okay? Because where you're standing here, that become your location, okay? And if a person is standing there, that become his location. So uniqueness is there. So everything is related to everything is, that is how he's saying that. In GIS, so we don't require any kind of a primary key to identify, okay, particular land or particular piece of the tile, okay, what is the primary key for that? Because the geo coordinate itself become the primary key for a particular that object. That's why he's saying that everything is related to everything else, but near things are more related to than the distance thing. Okay, so that's generally statement by given by his about the GIS side. So let's understand first the fact about the GIS. What is there? I think the maybe some all of people might know the full form of the GIS, like Geographic Information System. So it's like a special tool that help us to understand, analyze the special data. I mean, I say special data, right? The data which talk about a geo coordinate. Okay, that will be always we have a geo coordinates along that. So if particular point I'm taking it, it might be one point, it can be a multi-point. So we'll talk about in the next slide what kind of data type will be coming across that one. So just to give a generalized statement and the very close to a real life one, okay, which houses are closest to the park, what are the fastest route to deliver pizza, and what are the best place to the plant the tree. And I think every one of our daily routines, we are already using the GIS our day-to-day routines, like because we cannot live with our pizza delivery. Okay, we cannot live without the Grab in here Vietnam, in India, in the Uber, like that. So everyone is using GIS. Without a GIS, and even we are living with the Google Maps also. That's how exactly it works, right? So this is about the GIS. That's the fact about and reality about the GIS. So nothing like a complex, which is new topics has come across in industry. Nothing like that. So before I go talk to the next slide one, right? This is like a current market forecast is there up to the 2025. There are a lot of forecasting has been done by analysis team, but it's saying that like the market is going to be grow and is going to be grow by almost more than $14.5 billion by 2023. So there are a lot of the opportunities going to be come across it, and most of the countries, their government are investing a lot of the monies into the GIS domain, because if they wanted to configure all the data which is available to the GIS one, like example of property, investigations also, and cropping part, everything they wanted to do it by link it to the GIS side. And that is why this market is growing very fast and is going to be a good, create more opportunity in like future. Okay, there is a disclaimer here. So I'm not a market expert. I'm just a learner. So whatever I found in a analysis PDF, I just grab it. Yeah, so this is some few fact about a few things currently what's happening in across the world. I have picked around that one, like so. But title says that GIS is evergreen a trend. I will tell you why. GIS was there exists since our Earth has born, and it will be there GIS till the Earth will be here. So it will not go anywhere. Okay, there is a lot of technology trend will come and go away. Like earlier to have a computer, desktop, then computer, then a mobile, a laptop, right? Now is the AI is going on trend everywhere. So the technology trend keep on changing it. but GIS will be there every time. That's how I'm telling about GIS is the evergreen trend. There are some people are doing like in India there is a state called Maharashtra. They are doing a property bindings using the GIS. So all the property taxes can be paid and can be upfrontly. People know that how that is getting calculated also. So each property will have a unique property ID, and that will be linked to the geo coordinate. Currently, that system is not there in some of the places, so people are starting using that. So that can be very transparent to the people who are paying the tax one. So they are a good initiative done by the Maharashtra government for that one. There's similarly a lot of things are happening in the world across also. And you can see this is from the news only. I pick up from the news report only, like these are the trends are happening in a GIS. And in America, like US is already using that GIS, because in Eagle View, we sell a lot of things in US markets only. There are a lot of like solar roofing is there. The insurance claiming happen through GIS. Okay, there is a change detection happen, like somebody is encroaching the other's land. How can I detect through the AIML with the GIS data? That can be also predicted by this data. There are multiple products are there using the GIS, and already a lot of countries are spending around that one. This is another few fact about, like, recently Indian government started using the geo more, and they're spending more on the investing more on. They had done a geo summit also recently. So that's the one Twitter snippets is there. So let's support now a little bit some more understanding about the GIS type, right? So GIS includes the 3 data types. There are more, but the primary are the 3 data types, which called about the point, line, and polygon. When I say point, I'm standing here, that's my points. When I say line, if I want to measure something from here to that particular standee, that become a lines here. But if I want to go beyond that, where we'll have a multiple point more than 2, which is like from here to there, maybe triangular, maybe square one, it can be polygons also. So that become a polygon. So most of the time land will have a polygon, road will have a line object, where your meter number or any water pipe will have a points along with that. So this is the example of that particular data type which comes in the GIS side. So what kind of format generally the data gets stored, right? So there are standard formats set by the geospatial information things, right? And S3 is one of the topmost company which define that everything here. So there are like GeoJSON, KML format. GeoJSON is a JSON file format where we can define that a particular GIS data into JSON format. I'll show you the one use cases how it can be look like that. The KML format, the shape format, and there are many more. But there are 2 formats are highly used, which is the GeoJSON and the shapefile one. So GeoJSON will be stored into in generally Postgres database, and the shapefile will be the file format. So in generally, if you want to transfer data of the any special data, right, I can hand over that shapefile to somebody else just by transferring the file. That data will conclude of the map and the points, whatever data will be there around that. Yeah, so I was talking about GeoJSON side, like that this is the format of GeoJSON file. We will have a feature collection. So it will say that type of data type is the feature collection, and what kind of types will be there. It defined that whether it's a point, whether it's a line string or a polygon. So as I mentioned earlier, right, a point will have only 1 coordinate here, and the line will have a 2 coordinate, like this and this, like that, and the polygon will have a multiple based on the points it covers that one. This is a shapefile format. So whenever there is a shapefile is getting distributed to the one hand to the another hand, that will be in this format. So 4 files are mandatory. Like one is the DBF file, which consists of database values. One is the PRG, which actually showcase the map on that side. And the shapefile will have actual data and linking between your geospatial point. And SSH is the another next level of extension for that one. So when somebody is asking for shapefile data, has to be there the 4 file inclusion of that. Any of the file is missing there may not have the full-fledged data. So we'll have to ask again for that file. So make sure that whenever you're dealing with the shapefile data or geospatial data, this 4 file has to be there. Even if you convert from the GeoJSON to shapefile or any other format, KML format, that's how exactly works. The 4 files should be there for the conversion part. So we can have a multiple shapefile for that one, and you can club together with the one shapefile also. Yeah, so now main part is like PostGIS here. Why is the PostGIS there, right? So as this picture says that it's the fastest thing on earth, go like a cheetah. Okay, but yeah, it is true. Is there compared to the other database for a GIS support? It is very fast compared to because that support the special indexes and has a good kind of B-tree mechanism and index mechanism is there, which actually run the query faster compared to the other database for the geospatial data. There are a lot of other databases are available already. So PostGIS actually is the extension of the Postgres database. So you might have like learning from last 2 days about the Postgres in this room, right? So PostGIS is actually extension of PostgreSQL database management system, which actually store the special data. It can consist of type, indexes, and functions. So I'll just skip this history, so limited of time. Yeah, so this is one important slide of that here. As I mentioned, my early talks also here, just now. Earth is your primary key, and spatial is a universal key by itself. So make sure that when you're dealing with the geospatial data, your geo coordinate itself is a primary key. You don't require, you don't require any extra primary key to define that. When you have a column, automatically your coordinate becomes the primary key for that one. So that's another amazing part of the geospatial data. You don't have to worry about, okay, what my column will be there and what can be a primary key for that one. These are the functions available, which actually Postgres has an inbuilt function compared to the other database. There are a lot of the functions are available, and one of the good part is like as some of the session has mentioned, right? Postgres has one of the active communities to create a lot of extension, a lot of different support for that, and these lists are keep getting increasing every times, right? So these are common. I'll just walk through on the small functions like it's HT area. So if you have a GeoJSON there, you can just directly run the query with the HT area and the column where we store the GeoJSON values in a database, which will have that. It will automatically give the area part of that. So that's how exactly work. You don't need to write any separate function for that. The inbuilt function already is there. Same for the HT within also. Like example, if you want to find out which are the hospital within my area of zone, right? You can just write this query here and you will be able to get, let me see that, query is here. You can find out a within query. I can find out, okay, my house geo coordinate and the within the area coordinates will be there. So accordingly, it will give a list of all the hospitals available within my area. Same is like work like I would grab while you're grabbing it, like when you play, it will pull the nearest drivers which is available to your location. So there are some more functions are available, like as I mentioned, right? Intersect, cover DB, cover disjoin, equal, overlap, touches. These unions are there, and there are many like that. This is how exactly that the Postgres tables will be created, like create table, like simple like a MySQL or other database, like same like that we can do it. Only thing is we have to define like geography at the type of that and which are the point you're going to store it, like whether points, lines, or polygon. So there are real world of GIS. I will quickly walk through on that. What are there? Where is exactly using this? Yes, the GIS getting used into hardware and software, both industry, not like only software industry also. Along with that, different market segments are there, like agriculture, construction, transportation, utility, mining, oil and gas. So let's have a look into the like how healthcare can be used, right? I think Corona time, a lot of people have been developed a lot of application using the geospatial data to find out where is my vaccine is available when nearest hospital or nearest center around that, or where is actually the more density of the COVID patients are there that can be identified with the GIS data. So people have used this, and nowadays all pharma sector are utilizing this way. Agriculture, I think well known that cropping side, water management of the crop, everything can be used in agriculture. There are a lot of people are building the products around that. Yeah, so that's about my talk. Okay, you can scan this code. I have listed all the resources which is done by whatever research of this particular talk. It is available in a GitHub. All the list of the links available there. So you can scan this QR code.
Okay, thank you for flying through the GIS talk. There's a lot over here. Do we have time for questions? Any questions from the audience? Yes, GIS is a very specific subject. I have, since nobody has a question, I always have a question. What is the standard GIS system that you use, or Postgres comes with it when you actually use PostGIS, like the international standard?
International standard, there are different standards are there. The
Yes.
CRS standard you use it.
Yes.
So CRS 84 something there.
Something.
PRG 45.
Okay.
That's the,
All right. The other question. I have,
PRG.
Can I ask another question? Okay. Is there a data type that supports the latitude and longitude, or you use just integer?
No, I didn't.
When you store the geolocation, is there a special data type that supports this in
No,
Postgres?
nothing like that. All data type which is under the GIS, like line, the polygons, and the point. Anything can be there.
Correct, but the data type, when you define a table.
No, the data type is geometry.
Okay.
Geometry and geography. There are two data types are there.
Okay. All right. That's the answer. All right. Thank you very much.
You may call me Ivan Kush. I'm from Tantor Labs. We develop database that is based on Postgres. So in this talk, I'm going to tell you about one of the possible implementations of autonomous transactions. So autonomous transaction is a transaction that may be committed even if the main transaction is rolled back. They are not in SQL standard, but many databases use them with their own syntax. In this example, a common use case is to declare a block of SQL statements with some attribute. On this example, we declare the function with pragma autonomous transaction. That means that this function will be executed in the different session. Let's analyze the example. In the main transaction, we execute begin. It does start the transaction. Then we insert the value 0 to the table. Then call the function for. It inserts value 1 to the table. And then execute rollback. So our main function should roll back. And when we select from the table, we see that value 1 is in the table and value 0 not in the table. So value 1 was stored, although the main transaction is rolled back. So common use cases are logging, auditing, integration with some external IP, debugging. Also many databases use them. So when we try to convert code from other database to Postgres, we could use such construction. Also, non-transaction commands may be executed in autonomous functions like vacuum and many other, create table, etc. So a bit of glossary. Main session is the session through which user interacts with the server. Main transaction is a transaction in this session. Autonomous session is an independent session that is created from main session. And autonomous transaction is AT. Autonomous function that will be executed in the autonomous session. So autonomous transaction characteristics. So this is independent transaction that don't depend on the state of the main transaction if the isolation level is serializable. Also, autonomous transactions can launch another transactions. And this is a high-performance alternative to extensions like dblink and PG background. So here examples how used of the syntax of autonomous transactions in different databases. Three below are Postgres-like databases. They have two types of syntax. Maybe we have another databases, but I don't know about them. I mean about Postgres. So we skip some slides because we have low time. No, here examples how I used in different databases. So we don't have autonomous transaction in Postgres, but we have extensions that have such functionality, like dblink, PG background. Also, we can use PL Python for such behavior. But they all have some disadvantages. Performance and security. For example, PG background uses background workers, and for each function execution, we create and destroy background worker. And dblink has security problem that passwords are stored in plain text. No party and skip. So a bit of history. First nodes of when we try to realize autonomous transactions, many questions arise like security, implementation, semantics, replication, and many other things. We need all solve it. That's because I think autonomous transactions aren't in the Postgres at the current time. So those discussions in hackers were from 2008 till 2011. They discussed the concept and semantics of autonomous transactions, but no patches were introduced. In 2014, Rajiv Rastogi, a guy from Huawei, have introduced the first patch with implementation. He have used PGPro data structure for storing autonomous context and return to the main context. So we have only one process that implement main transaction and autonomous transaction. Okay. In 2016, Peter Eisentraut also introduces a patch. At the time, Postgres have had background workers, and so Peter used them to implement autonomous transactions. And so I think I skip this a bit. So he has some advantages and disadvantages, and based on Peter's patch, we implemented our patch that has some common internal characteristics. So we don't have Python at the current time support, but we have PGSQL support using Pragma autonomous transaction. We implemented using background workers, synchronous execution. For communication used Postgres client server protocol. Messages are sent through dynamic shared memory. Infinite nested calls of autonomous transactions are possible. So we have pool of autonomous sessions for which backend. More statements are supported than in Peter's patch, and many tests. So here's the link if you like to read. So let's see an example. Here's an anonymous function. Here's a Pragma autonomous transaction, and in the function we have transaction management commands like start transaction, comment, and rollback. By default functions, we can't use transaction commands. So the advantages of the patch that we have pool of sessions, no need each time to create and destroy background workers when we execute an autonomous function. Also, many statements are supported. Almost no need to refactor as current Postgres code. We use the generally accepted Pragma autonomous transaction, and it works. Some disadvantages. It uses background workers, so we need many systems Postgres use them. So we need somehow to split background workers that are used in autonomous transaction from other using, because no, we could use many times transaction, and the background workers will be exhausted. So the next step is need a common pool of autonomous transactions for all backend. No, this is for security, rule system. It's better to have. Also, from Peter's patch, 7 years has passed, and community now doubts, do we need them in the core Postgres? And how we need to implement them more generously. Maybe we don't need them in the Postgres, and somehow with different mechanism could implement the needed functionality. So now about internals of implementation. Dynamic shared memory segment is allocated at first. Then table or shared memory table of contents is created. Table of contents is a dictionary whose values links to addresses of other entities in the rest of the DSM. So, and then the entities itself allocated. We have 4 entities, user data. They contain some authentication information. Then we have 2 shared memory message queues through which communication between main session and autonomous session will be. And then the settings of the main session that are used in the autonomous session. So we have such segment, then we launch a background worker, past the handler function to it. Background worker is created, begins to execute handler. Handler reads all this data and internalizes structures for autonomous session. Then send the message to the main session that it's ready to execute commands, and the infinite loop begins. So let's see example this. So we have a function with pragma autonomous. It will be executed in autonomous session. So autonomous session was created, and main session we have. So we have a command execute and sort into table values. It's parsed by main session. Insert command is extracted. This command is sent. This command is sent to the autonomous session. It was executed there, and then back the command zit. That means complete, and main session continues its execution. So we have a pool for which backend it's created lazily. We have destroying of sessions by timeout. We needed to clear memory because caches occupy it. And no, this is not beautiful, but simple solution at the current time. After execution, autonomous session is returned to the pool. At the current time, tell the truth, only one session is sufficient, and we have synchronous execution between main and autonomous sessions. But as some statements not supported, sometimes we need more autonomous sessions. So let's see examples. We have a table with integrity constraint. All our values should be greater than 500. We have autonomous function with 2 inserts. They executed in 2 transactions. At first, we insert 700 and then 100. It violates constraint, so the transaction is rolled back. And table contains 700 only. The second example is all these inserts are in transaction block. They are executed in 1 autonomous transaction, so we also insert no, 820 violates the constraint, so all transaction is rolled back and our table is empty. So it's possible to execute non-transactional commands like vacuum and many other, alter system, and so many other. Exception handling is possible. We have here two races, one notice and one exception. Exception was catched from other function. And so when we execute this function, we have one notice and we have notice about exception that was catched here. At the current time, we have, it's possible to use transaction management commands in procedures, but they have some not very beautiful, we may say it. So let's analyze the procedure P2. At first it inserts 100, then commit command, and then 800 rollback command. After first commit, our main session, one transaction is completed and automatically was started the second transaction that was rolled back. So we have in the table only 700. But it's impossible to call a procedure that manages transactions from a simple functions. We have an error. Here is a function that calls our previous procedure, and we got an error. So it's impossible to execute also non-transactional commands in the procedure. We call here vacuum, and it's impossible to execute. We have an error. Also, Also procedures don't return values. So it's a disadvantage because we can't use in some operations. Also, we have a different syntax to call procedures and functions. We have some time to rewrite them. So some benchmarks. We have a double link implementation with PG background implementation. Also, we have Pragma autonomous transaction with pool of workers, and Pragma Peter means without pool of workers. As we can see, with more connections, we have more TPS using pool. So pool is a cool thing. So here's a code for benchmark. I think it's not interesting for now. And the third plans, we try to implement remaining statements in PGSQL, also Python support, common pool for all backends, asynchronous or autonomous transactions. And of course, we try to solve all questions from reviewers and merge to master, but maybe will be simplest as an extension. No, that's all.
All right, we have time for questions. Any questions on the autonomous transactions?
No, so thank you.
Thank you very much.
Okay. Đầu tiên thì mình xin phép nói về các cái nội dung của hai ngày hôm nay. Mình muốn nói về vấn đề của Postgres khi mà nó đang sử dụng trong cái công ty của mình, có những cái vấn đề nào. Tiếp theo thì khi mà sau đó một cái vấn đề mà giải quyết ở công ty thì nó sẽ bằng hai ba công ty. Cụ thể thì chúng mình đã tìm đến một bạn để giải quyết một cái vấn đề về cái mục đi như thế nào. Và nội dung thứ ba đó chính là làm thế nào để sử dụng Patroni trong các cái môi trường hay là các ứng dụng của mình. Phần thứ tư đấy chính là cái phần demo. Nào, mình xin phép nói về một chút về công ty của mình. Thì bên mình là Bitfly, đang hoạt động như là một cái cloud provider để cung cấp các cái cơ sở hạ tầng cho internet. Thì Bitfly Cloud là một cái công ty mà sẽ đem ra các cái giải pháp về cloud server, load balancer, database và Kubernetes hay là database service. Thì khi mà trong cái quá trình hoạt động hay là giải quyết các cái vấn đề của ứng dụng hay là các cái bài toán của công ty ấy, thì bên mình đang có và đang cung cấp những cái vấn đề cụ thể. Thì là sẽ có rất là nhiều cái backend mà sử dụng Postgres. Tiếp theo thì đối với các cái ứng dụng đấy thì lại đòi hỏi một cái độ ổn định hay là các cái tính sẵn sàng cao để có thể là cung cấp được đến nhiều người dùng đồng thời. Thì vấn đề mà mình gặp phải đấy là cần high availability cho cái hệ thống Postgres đấy. Và giải pháp thứ ba là vì hoạt động như một cái cloud provider thì bên mình cần đóng gói cái Postgres đấy như là một cái database để có thể là database service để cung cấp cho user. Có vẻ hơi bị vỡ phông như vậy. Ok, thôi không sao. Thì các cái giải pháp mà tương ứng với vấn đề mà bên mình gặp phải đấy là gì? Khi mà có quá nhiều backend ấy, thì đồng thời sẽ có nhiều cái database đi kèm theo. Và khi mà kết hợp với HA thì bên mình sẽ cần phải đến các cái giải pháp liên quan đến HA Proxy và Kubernetes để có thể là hoạt động được. Và trong cái giải pháp cho cái vấn đề đóng gói sản phẩm thì là mình sẽ cần đến các cái native Postgres. Thì về các bạn thì đối với cái native Postgres thì không có cái vấn đề về HA và nó chỉ đơn thuần là một cái Postgres cài lên thôi, thì sẽ có rất là nhiều vấn đề cần phải cài đặt vào đấy. Giải pháp cho cái vấn đề về package thì là chúng mình đưa ra một cái giải pháp đấy là tự đóng gói. Tuy nhiên thì khi mà đóng gói đấy thì đã gặp phải rất là nhiều vấn đề liên quan đến quá trình bên tên nó rất là phức tạp. Nhược điểm của các cái giải pháp đấy thì là đối với cái giải pháp mà có nhiều backend server ấy, thì là chi phí nó tăng cao và có thể là nó không được tối ưu đối với cái cơ sở hạ tầng mà mình đang có. Đối với Kubernetes thì giữa một layer ở đấy thì nó sẽ xảy ra là timeout giữa cái hệ thống database và ứng dụng. Và giải pháp mà khi mà đóng gói thì nó rất là khó để maintain. Và việc self-service thì là nó bị tốn nhiều chi phí và mất thời gian. Thì trong cái quá trình mà tìm hiểu hay là tổng hợp trên các cái giải pháp ở bên mình ấy, thì bên mình đã tìm ra được là cái Patroni. Thì Patroni nó được xem như là một cái template cho PostgreSQL để có thể là cung cấp cái giải pháp high availability cho Postgres, và nó được hoạt động như là một cái mã nguồn mở open source, thì và có thể là chạy cùng với trên cái hệ thống on-premise hay là Kubernetes hay là Docker. Thì một vài lợi ích của Patroni đó là gì? Patroni thì về cơ bản nó có thể là tự động là monitor hay là giám sát các cái database node ở trong một cái cụm cluster của Patroni, một cluster của Postgres. Sau đấy thì khi mà nó đã giám sát được rồi thì nó có thể là tự động failover các cái hệ thống đấy. Cụ thể là khi mà một cái database server bị lỗi ấy, thì nó có thể là switch sang một cái con database mà đang hoạt động bình thường. Ngoài ra thì nó có cung cấp về REST API để có thể là điều khiển Patroni thông qua các cái giao diện HTTP và có thể là điều khiển được từ xa mà không cần phải truy cập sử dụng command line. Ngoài ra thì nó có thể là cung cấp được cho mình các cái cơ chế mà tích hợp với watchdog của Linux để có thể là tránh cái trường hợp split brain trong một cái cluster khi mà có hai node. So Thì vậy thì Patroni hoạt động như thế nào đối với một cái hệ thống trong cái hạ tầng của bên mình? Thì Patroni kết hợp với etcd để cung cấp ra một cái hệ thống trao đổi key giữa cái cluster đấy. Thì mỗi một cái etcd server ấy, nó sẽ tích hợp và quản lý bởi một cái định danh là scope. Thì các cái node ở trong etcd sẽ liên tục là gửi các cái key, update cái key đấy theo state ở trong một cái scope đó, và nó trao đổi với nhau để nhận biết xem là đâu là node primary để truy cập. Thì các node sẽ luôn tục giám sát xem là trao đổi cái key đấy và theo dõi định danh xem là ông nào nắm cái khóa chính đấy, thì tự động promote cái ông đấy làm primary. Thì đây là về cơ bản cái kiến trúc của Patroni. Thì Patroni là có bên mình đang thiết kế là đang có 3 lốt là PostgreSQL Patroni. Thì Patroni sẽ thực hiện là thành phần là giám sát từng cái PostgreSQL để quản lý thông qua cái cụm etc đấy, và application thì sẽ kết nối trực tiếp đến Postgre Patroni đấy thông qua một cái thư viện. Đây là cái kiến trúc của ứng dụng. Thì vậy thì qua cái kiến trúc đấy ấy, thì bên mình sẽ sử dụng như thế nào đối với cái Patroni? Thì về việc mà Patroni ở trong cái môi trường của chúng mình ấy, thì với cái kiến trúc thì là sử dụng để cung cấp là như một thành phần HA ở trong cái hệ thống đấy. Rồi thì nó sẽ đòi hỏi cái việc là sẵn sàng như thế nào, độ ổn định ra làm sao, và khi mà trong cái nhu cầu hay là cái ứng dụng của Postgre đối với database thì gần như là tất cả mọi cái lĩnh vực của mọi cái ngành nghề thì đều có sự xuất hiện hay là có mặt của Postgre. Thì Postgre nó đang chiếm lĩnh cái thị trường database gần như là thế, từ time series DB hay là từ AI hay là application. Và rồi thì trong cái quá trình mà cloud thì Patroni nó đang góp phần giống như kiểu là một core để manage cái database service ở bên mình. Đó, thì làm thế nào để mà có thể connect được đến Patroni? Thì cụ thể thì hầu hết thì các cái thư viện của Patroni đang được cấu hình, được compile từ một cái thư viện C để có thể là kết nối được đến Patroni thông qua từ Python, rồi thì các cái Java hay là các cái thư viện về .NET thì đều chung một cái thư viện C. Thì để có thể kết nối được đến với một cái cụm cluster Patroni thì chúng ta có thể là sử dụng một cái attribute, đấy là target section attribute. Thì đối với cái option param collect này thì sẽ có một vài giá trị, chẳng hạn như là any hay là free first standby, free read only hay là read wide standby. Thì đối với cái any thì nó có thể là chấp nhận được tất cả các cái server khi mà kết nối đến. Đồng thời thì khi mà sử dụng free first standby, tức là có một cái node mà bị lỗi đó, thì cái việc mà nó sẽ tự động là kết nối và switch sang một cái hệ thống secondary, và trong đấy thì cái node secondary đấy sẽ tự động là chuyển thành node primary rồi, và cái quá trình mà kết nối ứng dụng ấy nó sẽ vẫn được tiếp tục là diễn ra. Đối với cái việc mà kết nối đến cái standby thì tức là database sẽ chỉ kết nối đến cái node standby ở trong cái cluster đó và không sử dụng đến node primary. Thì như thế thì nó sẽ giảm tải được cho cái hệ thống database. Thì hiện tại thì mình có một cái demo nho nhỏ đối với cái việc là sử dụng với Python khi mà kết nối đến Patroni. Thì ở đây thì mình có một cái example code ở trong Python. Sorry. Ở đây thì mình sẽ sử dụng pscope đối với một cái list server cluster mà có cái một loạt các cái database hot mà liên quan đến Patroni ở trong cái cụm cluster Patroni đó, thì mình có thể là sẽ khai báo toàn bộ các cái hot ở bên trong này, và khi mà kết nối đến ấy, chúng ta sẽ sử dụng là attribute section để có thể là kết nối đến cụm cluster đó, và khi mà chúng ta có thể là lựa chọn được là đâu là cái node mà chúng ta mong muốn kết nối đến thông qua cái section attribute đấy, thì như vậy thì khi quá trình mà mình tắt đi một cái node database hay là thực tế là một cái node database nó bị lỗi chẳng hạn, thì trong cái cụm database đấy nó có thể là tự động đã đổi primary rồi, thì nó sẽ vẫn tiếp tục là kết nối được đến cái database mà mình đang chỉ định và mong muốn. Thì đây là cái bài mà mình muốn trình bày đến, thì về cơ bản thì chắc là mình xin phép dừng ở đây, thì hết. Thank you.
And you finished very early. Any questions? Yes, he has. Okay. 1 second. We don't have a translation problem.
Cho mình hỏi chút, mình quan tâm đến cái Patroni của bạn ấy. Thì mình hỏi là cái Patroni này so với cái keep lại thì nó có những cái đặc điểm gì hơn? Vừa nãy mình thấy bộ nhắc đến cái keep lại ở trong cái slide trước ấy. Cái gì hơn so với keep lại?
Rồi, đây thì ở đây thì em cũng nêu ra một cái vài nhược điểm khi mà bên em gặp phải. Thì đầu tiên thì bọn em khi mà nghĩ đến ấy, thì bọn em sẽ kết hợp là giữa là PG pool và hierarchy và keep-line, đúng không ạ? Thì giữa một cái layer đấy, nó tức là database của mình đã đi qua một cái tầng trung gian là keep-line rồi, thì đâu đấy thì giữa cái tầng đấy nó xuất hiện một cái đoạn timeout về network đó, thì tức là nó sẽ làm cho cái việc là kết nối qua trung gian và kết nối trực tiếp một. Thì bên em ưu tiên cái đoạn là đường truyền. Thì về một ấy, nó có hai yếu tố ảnh hưởng. Đấy là một là mình sẽ không phải maintain cái thành phần về hierarchy và keep-line nữa. Và đâu đấy thì đối với cái việc mà giảm chi phí ấy, thì bên em cũng không gọi là ưu tiên về việc là mình làm tăng cái độ phức tạp của hệ thống lên, và làm cái việc là đâu đấy thì cái việc keep-line nó cài lên trên đó thì nó đã chiếm mất một cái phần tài nguyên rồi. Thì về các bạn thì giữa vừa việc này tăng timeout này, vừa có độ trễ ở giữa cái đấy này, thì bọn em sẽ nó coi như là nhược điểm của việc là dùng hierarchy và keep-line. Thì khi mà dùng Patroni thì nó kết nối một, và đâu đấy thì cái thư viện của cái PostgreSQL ấy nó đều được biên dịch và nó tự tìm được đến cái con server rồi. Thì đâu đấy thì bọn em không cần dùng cái đấy nữa, vì bản thân cả nên nó dùng giống như kiểu MongoDB ấy, thì là nó tự tìm đến được đấy, thông qua cái section này. Yes. Thì khi mà kết nối thì mình khai báo rất là nhiều địa chỉ và thêm cái keyword này nữa thì nó sẽ tự kết nối đến.
Cho mình xin phép hỏi thêm một câu nữa là cái hệ thống của bên bộ ấy.
Dạ vâng.
Thì hai con máy chủ là theo hình thức master standby. Nếu mà master standby thì khi con master mà bị down ấy,
dạ,
thì con standby cái Patroni này nó tự dựng con standby đứng lên thành con master được không? Hay
dạ
là...
vâng, chính xác. Tức là bên em sẽ có thường thì một cluster sẽ có 3 node, đúng không ạ? Đấy là một cái cluster cơ bản. Thì khi mà cái cluster đấy nó có nó hoạt động theo hình thức là primary và secondary, tức là kiểu primary và standby đấy ạ. Thì khi mà cái con primary nó bị down ấy, thì cái con secondary nó sẽ tự động được forward lên. Một trong những con secondary sẽ được forward lên làm con primary. Thì nhờ cái key này nó sẽ tự động kết nối được đến cái app, nó sẽ tự động biết được đâu là con primary để nó kết nối đến tiếp, và cái quá trình đồng bộ dữ liệu ấy thì nó sẽ vẫn được tiếp tục xảy ra.
Rồi, cảm ơn bộ. Thì cái hệ thống của bên bộ là phải có 3 máy đúng không? Thế thì có 2 máy thì có ok không?
Câu chuyện là có 2 máy thì vẫn hoạt động được bình thường. Đấy thì về theo lý thuyết thì mình không nên dùng 2 cái cluster, gọi là 2 cái cluster đấy, tức là một cluster 2 node ấy, thì mình không nên dùng. Yes.
Anh cho em hỏi là khi một master bị down thì nó mất khoảng bao nhiêu lâu thì Patroni có thể promote một cái slave thành master?
Ok, anh hiểu. Thì trong cái khi mà cấu hình về cái Patroni ấy, nó sẽ có một cái về một cái keyword gọi là interval gửi cái gọi là interval health check các cái node trong cluster đấy, có thể là 15 giây, 30 giây hay là 1 phút tùy theo mình chỉ định. Đó, thì khi mà nó dùng chung với cái etcd ấy, và nó kết nối đến là một con nó down rồi, nó không update cái key đấy nữa, bởi vì mỗi một cái key sẽ có một cái trạng thái ở đó. Thì khi mà khi mà kết nối đến etcd ấy, cái primary key nó không có ai hold lại cái key đó, thì một con, tức là các cái con secondary còn lại nó sẽ tự động bầu xem là đâu là con primary, thì con đấy sẽ, khi mà một con được bầu lại thì nó sẽ nắm cái key trình đấy và nó nên làm primary, thì các con còn lại sẽ theo cái con đấy, và quá trình đồng bộ thì nó sẽ tự động đồng bộ giữa các cái node đấy lại với nhau theo cái con primary mới. Giúp đúng rồi. Chuyển từ lên smarter thì nó cấu hình nhanh lắm, nó đâu đấy thì theo như bên anh nó chỉ mất khoảng 5 giây thôi, bởi vì nó là hot standby mà, hot cấu hình kiểu đúng không? Chắc chắn là nó sẽ retry rồi, bởi vì là nó dựa theo cái key này để nó retry đến thì nó sẽ bị time out rồi, đúng không? Nhưng mà sau đấy thì em hình dung là khi mà cái key nó đã được xác định rồi ấy, thì một con free mới nó đã lên rồi, thì như thế thì nó vẫn tiếp tục nó kết nối được đến con free mà.
Okay, thank you. All right, this concludes our day here.
Yes.
Thanks for all the speakers and thanks for joining. We'll see you
Okay.
tomorrow.
Thank you.
You don't have anything over here. This is yours. Don't forget to take that.